Okay, so the couple of things we didn't get to last time. It's factor by grouping. In factor by grouping, there's only one situation where factor by grouping works. It only works if you have 4 terms. Well, everything we're going to look at, we're doing 4 terms. There may be some other times where you might could do something different with it. But everything we're going to look at, it's where you have 4 terms for this thing. And it basically is this. Sometimes, depending on how it is, as long as it's in descending order where you start with your highest power and you've got it working down, you're always going to be able to go back and group the first 2 terms together. And then you're going to group the last 2 terms together. And all you're going to do from those 2 different sets of parentheses that you have is you're going to take out the greatest common factor from each set of parentheses. Okay, and then the last thing you do with this one is that you're going to basically put the GCF. So that's your first step, group the different pairs here. Take out the greatest common factor. And then the last part where you kind of put it all together is the GCF from, let's say, both pairs. I don't know if the wording is the best in the world here, but the GCF from both pairs of parentheses, because you've got the first 2 terms and the last 2 terms. Once you've taken and found the GCF of both of those 2 things are together in one set of parentheses. Okay, and one check this with grouping is take out the greatest common factor from the first 2 terms. You take out the greatest common factor from the second 2 terms. Whatever is left, once you've taken out the greatest common factor, what you have in the parentheses has to be the same. If it's not the same, either number 1, you did the factoring wrong, or number 2, you did the factoring wrong. So you don't really have a choice. It's kind of one of those options of, if you look at it and you go, all right, well, there's no other way I can get this answer, then factor by grouping doesn't work. I mean, there's no other way around it when you go through these parts of it. So let's give you an example here where we've got some numbers to look at. Let's go with 2x to the third plus 7x squared plus 10x plus 35. And again, as long as it's in descending order, you can always, and some people will tell you that sometimes you rearrange it so that they have things in common. As long as it's in descending order with the powers, there's always going to be something in common with the different parts of it here. So once you've got that written, you'll basically put a parentheses around the first 2 terms and put a parentheses around the last 2 terms. And for me, just so I'll give you one here in a minute where you got some negatives involved. If you have negatives involved, I always tell people, just make sure you've got a plus sign between the 2, because you need a plus sign to separate the 2 sets of parentheses. So we're going to put a 2x to the third in the first parentheses. And then and if you want to go ahead and put the plus with a 10, that's fine. You've got a plus 10x and then plus 35. Because if that was a minus 10, you'd have to take the minus 10 instead of put the 10x. with the first two terms, 2 and 7, nothing in common there, but you have x to the third and x to the second. So for that one, you can take out an x squared. So that one, you'll have the 2 left over, take out 2 of the x's, you've got 1 left. Take out the 2 x's here, you've got the 7 left. And the good thing is, if you're pretty confident in that number is 2x plus 7, you already know what the next parentheses is going to be. When you take out the greatest common factor, that part has to be 2x plus 7. If it's not, you've done something wrong. That's what it comes down to. 10 and 35. You can divide them both by 5. 10 divided by 5 is 2. 35 divided by 5 is 7. So there you've got the same thing in the parentheses. And again, if you get something different, you know that you've got to check your factor by group, because those two things have to be the same. All right, and then what we've got from there is whatever you took out, the greatest common factor part of it. Those two things are going to go in one set of parentheses. Make that x squared plus 5. And then the other common parentheses you have with the 2x plus 7, that's just going to hang out behind it there. Now, the one question most people have when they get to this one is they'll ask, shouldn't that be 2x plus 7 squared? All right, well, let me ask you this. Here's kind of to answer that question with a question. If you had 7x plus 5x, do you get 12x squared? You don't, do you? So as long as you're adding numbers, and that's basically what this is almost like these are your variables that's here. So when you look at this part of it, this is a variable. Now it's a big variable, if you want to think about it that way. This is a variable. Those are like your x terms in this thing. That you're going to add the numbers that's in front. That when you do 7x plus 5x, technically, you're going to do 7 plus 5, and then you're going to put the x term behind it. That's technically what we're supposed to do. So if you're adding and subtracting, you don't increase the powers. You just add the numbers for whatever you do for that part. Because that's usually the one thing that sometimes people get a little bit lost on. Now, if you were multiplying, yeah, you would put a squared in there. But adding and subtracting, you just add and subtract the numbers that's in front of whatever you have that's the same. All right, let's give you one more of those. And then we've got one more factoring thing we need to look at. Only with 4 terms. Yep. Okay, so for example 2, we're going to do 4x to the third minus 3x squared minus 20x plus 15. And with when you have negatives, again, it's the same steps. You just have to be careful because sometimes if the sign is off, sometimes that lets you know that maybe the grouping was wrong when you go through these. Okay, so first 2 terms, we're going to put those together, and then we're going to have the last 2 terms together. So we've got 4x to the third minus 3x squared. And again, even though there's a minus sign in the middle, I always tell people automatically put a plus sign in there because you need to have the 2 terms added together. That way you know the negative has to go inside with the 20x. Because sometimes people, well, they're like, well, do I put the negative in or do I not put the negative in? And sometimes people will tell you it depends, and I tell people no, you put it inside every time. Always have a plus sign in the middle when you go through this. Okay, so now you're looking greatest common factor. 4 and 3, nothing in common, but you have x to the third and x to the second, so you can take out an x squared. So it leaves you with a 4x minus 3. And again, if you feel good with that one, you know that the next parentheses is going to have a 4x minus 3 in it. 20 and 15. Now, you can take out a 5, or if you just take out 5, what's that first term going to be? It's going to be negative 4, right? We know this one's got to be 4x minus 3, so that's the part that kind of lets you know that, again, these two things have to be exactly the same. If they're not exactly the same, you didn't take out the right greatest common factor, so if you take out a 5 and make that a negative 4, they're different, so you actually have to take out a negative 5. So you got negative 20 divided by negative 5, that's a positive 4. When you do 15 divided by negative 5, that makes it a negative 3. And that way, it kind of forces you to take out the right side of the number when you're going through this. Okay, and then putting it all together, you've got the x squared minus 5. We'll go together there, and then the 4x minus 3 is going to just fall in right behind it. Okay, so factor by grouping, it's only 4 terms, and that's the only thing you can do with 4 terms, is pair the first 2 together, pair the last 2 together, and again, as long as they're in descending order, you can do that. Put them together, and again, whatever you have that's in common that you take out, those go in one parentheses together, and the common pieces that you had just falls in behind it. All right, and the last thing we've got to look at. If you can remember to factor out a negative 1, you could. So, I mean, if you've got a way that works to kind of do that, that's, yeah, you can do that. So if you can think through it in your head, then absolutely. Yeah. All right, and the last thing that we'll look at is factoring-wise, it's one of the least things that you'll ever do, just because it's a special case and these very rarely pop up. And this one is sum or difference of 2 cubes. And again, this is something that you'll only use it every now and again. It doesn't pop up that much. There may be one problem that we'll do after we get through the factoring part of this one. There may be one time where something like this might pop up, but for the majority of the time, you're never going to see these. And the thing is that when you get this one, there's not a whole lot of work to these problems. So if you start off with just something cubed, if we do the sum first, we've got x cubed plus y cubed. This is one of those, it's a formula, you memorize it, and there's nothing else you do to it. And we'll actually give you one with some numbers here in a second so you can see it. But if you have x cubed plus y cubed, you're going to have x plus y. Minus xy, and then plus y squared. And that's it. That's all you do. There's no plugging in, there's no factors of this and grouping, and no, that's it. You take those, whatever you have, you plug it in, and that's all you can do. There's a very small amount of simplifying you can do when you have some variables. With a difference, it's the exact same numbers, exact same variables, exact same powers. The only thing that changes are the first 2 signs. So when you go from plus to minus here, you change the first one and you change the second one, but the last one stays the same. And that's the only difference between the two when you go through this one. So if you can memorize one of the formulas, if you can just remember to flip-flop the first 2 signs, and the way I always kind of remembered it was, if this is a plus, the first one's a plus. If you're doing subtraction and that's a minus, then the first one's a minus. So they kind of paired up in that part of it. Okay, now here's the kind of problems that you'll see when you're going through these. They're going to tell you to factor x cubed plus 8. Okay, and the very first thing you've got to do is you have to have two cube numbers. And 8 by itself is not a cube, so what you're going to do is you're going to think about this one, that x to the third, that's okay because it's x cubed. With 8, what can you rewrite it as so it's something to the third power? 2, right? You do 2 times 2, that's 4. Do 4 times 2, that's 8. And there's your 2 cubes. So all we're going to do for this part is, everywhere in this part of the formula that you had for y here, you're going to take y and replace it with 2. So in that formula, everywhere you have a y, just take out the y and replace it with a 2. Okay, so we had x cubed plus, take out, sorry. I was going to write the formula out, but I think we'll just kind of skip through it here. My bad. So you're going to do parentheses, x plus, again, take out the y, we're going to make it a 2. You're going to do x squared plus x, and that's technically x times 2. Oh wait, that's minus. And then plus 2 squared. And there's only really, well, 1.5 things you can do for this one. The x plus 2, nothing you can do there. X squared is good. Most people like to rearrange this one to put the 2x first because we're noticing you're seeing 2 times x and not x times 2. So just rearrange that and make it 2x. And then 2 to the second power is 4. And that's your answer. So it's just a matter of taking the numbers and plugging in the formula, and that's it. That's all you can do with it. It seems like you could do more, but when you start checking, because some people, most of the time the thought is, oh, I'll just find the factors of 4 that equal 2. Okay, find one. And I'll give you $100. Because there's not one. You can either do 1 times 4. If you add it, subtract it, that's 5 or 3. You've got 2 and 2. If you add it, it's 4. If you subtract it, it's 0. There's no pairs of numbers that you can take with 4 to factor off to get it down to -2. So for that one, that's as far as you can go. That's all you can do with it. All right, let's give you one more. Let's give you a minus one here. Let's go b to the third minus 125. And again, the very first thing you have to do is you've got to take 125 and rewrite it as something to the third power. 5, right? 5 times 5 is 25. Multiply by another 5, that gets you 125. So that's 5 minus, or b to the third minus 5 to the third. And it's the same thing for this one. Everywhere you had a y before, you're going to replace y with 5. Okay, and if it was minus, we're going to start off with the parentheses, x minus. Here's where we plug in the 5. Times x. And again, the first sign's always the same. That's the part I always kind of remembered when I had to memorize these two. The first sign's always going to match up. The second sign is going to alternate. So if you start with a negative, the next one has to go positive. So we've got x squared plus, technically it's x times 5, and we'll rearrange it here in just a second. And then plus 5 squared. And again, only two things you can do. You can rearrange the 5x. So You have x minus 5. X squared is good. Rearrange those two just because it looks better to us that way. And then do the 5 squared at the end and make it 25. Yeah, and let's replace all the x's with b's. Because if you do that on Alex, it's going to count it wrong. So, see, that I was just checking to see if anybody was paying attention.